Now this is the final activity, and this will be based on thermoregulation, just to help you understand. So we are given a graph on the left, which is indicating the body temperature, and as I had indicated that scientifically the body temperature, the normal temperature is 37. So what it normally tries to do is to ensure that the temperature, it is at least closest to 37 degrees Celsius. And if it increases or decreases below, then your skin is going to try to regulate that temperature. And the control center is still the hypothalamus in the brain. So let's answer a few questions there and see what if we can apply our understanding. They say, which part of the brain responds to the temperature changes that occur at A and B on the graph? So you have your A here, this is the increase in temperature, this is your increase in temperature, and then B is a decrease in temperature. Right, so the part of the brain that responds to that will be the hypothalamus. That is your hypothalamus. And then they say, what was the maximum temperature reached? Now the maximum temperature, if you check here, it is it's probably around 37.5 degrees Celsius. That is the maximum temperature reached. Then they say, for what period of time did the person engage in a strenuous exercise? As you can see, this temperature, due to activity, temperature, the body temperature started to increase rapidly there for about 20 minutes. Then after 20 minutes, that's where it started to decrease back to normal. So I would say that this person had engaged in a strenuous exercise for 20 minutes according to the graph. Then they say, now, why should the body temperature not allowed to fluctuate too much? They're taking you back to grade 10, where we know that enzymes in the body, enzymes are sensitive to temperature. Temperature changes. So your enzymes, remember, are very important. They are biological catalyst. So this biological catalyst is very important for many reactions. But now, for it to function properly, temperatures must be at least around 37 degrees Celsius. If the temperature increases or decreases too much, therefore you are going to denature the enzymes. So they're sensitive to temperature, and enzymes may denature. These enzymes may denature due to these temperature changes. Now they say, what diagram 1 or 2 would represent the condition of the skin after 15 minutes? So going back to the graph, let's see, after 15 minutes, oh, there it is. Oh, there's the strenuous exercise. Hey, there's the strenuous exercise. There is the cold shower. Wait, strenuous exercise, therefore it did not take 20 minutes. It's, let's say this is 5, 10, and then this is 15. So it's 15 minutes, not 20 minutes. I didn't see that. So the answer is 15 minutes. Right, so the answer is 15 minutes here. That's where the person has engaged in that strenuous exercise, and that resulted in the increase in the temperature there. Thereafter, they took the cold shower at 18 degrees Celsius. That is why the temperature decreased. So I think this person was attempting to cool down, but the body temperature had already returned back to normal, so the temperature had to now again increase. So let's see, let's go back to question 5. They are saying which diagram 1 or 2 would represent the condition of the skin after 15 minutes. So this is the skin here. This is how your skin would look like, and we know that if the temperature increases, the blood vessels are going to dilate. As you can see here, there's a dilation of the blood vessels, and also you're going to have your sweat glands being active. As you can see, there's the sweat. So that will be, if they're saying this person for 15 minutes, after 15 minutes, there it is. After 15 minutes, the temperature is very high, so he needs to lose all that heat through radiation, as well as what? So more blood will be sent, as I'm already explaining here. More blood is sent towards the surface of the skin, and temperature is lost through the skin via radiation and conduction, and also the sweat glands. The sweat will evaporate and cause a cooling effect. So now they're saying we must explain that, so I'm gonna write it in words. How do we explain how do we explain the whole cooling effect? Let's see, this is number 5. Point number 1, we're going to say that increase in body temperature due to strenuous exercise. That is our stimulus. Due to strenuous exercise, therefore warm blood will pass through the hypothalamus, right? And therefore the hypothalamus will be stimulated. This will stimulate the hypothalamus to do what? It will stimulate the hypothalamus to send impulses to the blood vessels, the skin, as well as the sweat glands Now the blood vessels are going to dilate. Blood vessels will dilate, and this is what we call vasodilation. Oh no, blood vessels will dilate, and this is what we refer to as vasodilation, and more blood is sent to the surface of the skin, right? So since more blood is sent to the surface of the skin, then more heat is lost. More heat is lost. This is through radiation and conduction. You don't have to mention that though. You can just say more heat is lost through the skin, and sweat glands are active. Sweat glands become active. Sweat glands become active. Sweat glands become active and secrete more sweat. More sweat is secreted. More sweat is secreted to the skin. Then the sweat evaporate. The sweat evaporate. Evaporates and creates, or just cools, and it cools down the body. Evaporates and cools down the body, and as a result the body temperature will decrease back to normal. Right, and that's about it. Hopefully that helped.